Welcome once again to Scientist Arena. In this video, we shall be talking about progressive and stationary wave. In our previous video, we've talked about the progressive wave where we talked about the equation of progressive wave. Alright, but then I'll be helping you understand the difference between progressive and stationary waves. Alright, so now progressive wave is a wave that transfers energy from the source of disturbance. Alright, while stationary waves don't transfer energy because stationary wave is a superposition of identical waves but in opposite direction. Now let us take let us have a pictorial understanding of that. For progressive waves now, we have, let's say we have it to be like this, transferring energy. All right, we could also have it to be like this. Okay, we could also have it as constructive interference, where this is like this, and then we have another one like this. All right, these are examples of progressive waves. But then when we talk about stationary waves, I said superimposition. Stationary waves now. For stationary waves, we could say destructive interference, superimposition of the same but opposite direction. So we just have, let's say we have it going from here, and this could also be caused by reflection. All right, so the waves are going like this. So let's say there is a boundary here. There is a boundary. I know it's not straight enough, but let's say this is a boundary. So when it reaches this point, it reflects back. All right, it reflects back and keep looping over. All right, so this is an example of what? Stationary waves. So this also could be as a form of destructive interference. Please don't mind my drawing. This also could be as a form of destructive interference as this as constructive interference. So we've talked about this in our previous classes where we talked about this as the amplitude that remains the same actually. We talked about from here to here being a wavelength, here to here being a wavelength, crest to crest, two consecutive crests or consecutive trough or 2 points in phase, all right, as wavelength. But here that is not the case. All right, here we have what we call nodes and antinodes. So this is a node. All right, the point of minimum displacement is a node, and the point of maximum displacement, which could be our crest, is our antinode. A for what? Antinode. N for our node. All right, so it is the point of what? Minimum displacement and maximum displacement, our amplitude. All right, so now in stationary waves, take note, let me add it here. Energy is not transferred. We can also, energy is not transferred, we can say it comes from destructive interference. What else could we say about stationary waves? Okay, I will add that later. Why for this we have that energy is transferred. Energy is transferred. Could be from constructive interference. All right, here is going in same direction. Right here it is going in opposite direction, which could be as a result. We can say as a result, which could be as a result of reflection. Don't forget, reflection has to do with the bouncing back of waves when it meets a material with minimum absorption. All right, so you can see that the wave was going just as I explained, and then it bounced back. So here it is still an identical wave. Do you understand? It's an identical wave. It is the wave itself that bounces back. So we expect the amplitude, the wavelength, and frequency of this wave that is coming the opposite direction to be the same. All right, so they meet at different points. All right, they meet at different points, superposition. All right. So now another key difference is that in progressive waves, our wavelength is from crest to crest. All right, but here now our wavelength consists of 3 antinodes. This is an antinode, this is an antinode, and this is an antinode. Don't mind my drawing, please. So the difference between here to here is half wavelength. Right, wavelength over 2. That's the difference between two nodes. The difference between two antinodes is equal to half wavelength. Even the difference between two nodes, this is a node here, let's say this is another node here. The difference between this is also half the wavelength. All right, so we can say that from here to this point now gives us a full here to this point now gives us a wavelength. That's from this node to the second node. That's from this node, not consecutive now. All right, because now the main diagram of this wave now is that from here, when I was drawing, let me do that again. The main diagram of this wave is that it came like this. Let me extend this. It came like this, then bounced back like this. So you can see that from this point to this point actually is the what? Wavelength. All right, then it came back and crossed each other like this. All right, so if from this point to this point is the wavelength, it means this point here is what? Half. This point to this point is the wavelength. All right, that means this point now is half of the wavelength. Half of the wavelength. Now from this node here, let's just take this node. From this node here to this antinode is quarter. From this node to this antinode is quarter of the wavelength. Here's another quarter. So this will give us a total of half, just as in here. I hope you understand this. So we can say the distance between two consecutive antinodes or two consecutive nodes is equal to what? Half wavelength. Why the distance between consecutive node and antinode is equal to what? Quarter, equals to quarter what? Wavelength. So that is that about progressive and stationary waves. All right, although we use more of progressive wave, and for the progressive wave equation, don't forget we talked about that in our previous videos where we said y is equals to amplitude sine in bracket angular displacement plus or minus phase difference, where we talked about when to use plus, when to use minus. All right, and we also derived about 4 other. Okay, you can see that. I'll drop the link in the description below, so you can click on that and watch that series if you missed it. So with this, I hope you now understand progressive and stationary waves. Say progressive waves, energy is transferred. Take note, in stationary waves, energy is not transferred. Thanks for watching. See you in the next video.